Hello, a very good morning to our lecturer and my fellow friends. First of all, my name is Agustin Asap Anak Dundang, CD 180067, taking Engineering Labs Laboratory 6 from Sections 4. Today, I want to present an introduction of our projects. First is bats are fascinating creature that while being blind, it still has a vision that is sharper than humans thanks to the ultrasonic range mechanisms. Generally, an ultrasonic sensor is a type of device that uses sound wave to determine the distance to an object by emitting sound wave at the specified frequency and listening for that sound wave to bouncing back. Next is it can be calculate the distance between the sonar sensor and the object that recording the elapsed time between the sound wave being produced and sound wave reflecting. Next is the use of ultrasonic sensor make distance measurement convenient as the sensor is ideal for measurement distance between moving and stationary objects as the ultrasonic sensor use non-contact technique to determine the distance between objects in the air. Next is, furthermore, not only it is easy to use and reliable, it also can measure distance without causing damage. The ultrasonic distance sensor will be linked to positional macro servo motor by using Arduino microcontroller. Servo motor is a type of motor that will for precise the control of angular or linear position, velocity, and accelerations. It consists of a suitable motor coupled to a position feedback sensor. The control system of a servo motor with ultrasonic sensor are commonly used in the real-life applications such as the automotive door, certain control, and general protections. Last is a taking example of the use of servo motor with ultrasonic control system in the generally protection it by placing the setup around something that need to protective care. The minimum distance can be set such the buzzer will sound if anything come close or approach the objects.
Assalamualaikum and a very good day. My name is Aiza Nabila binti Awang Azman, metric number DD180094. I am from Group 4A and I'm going to present on the objectives, scope, theory of the experiment and also briefly on the circuit analysis. So first, I will explain on the objective of the experiment. Basically, the objective of the experiment is to develop an experimental procedure for the control system of a servo motor with an ultrasonic sensor. And the second objective is to estimate the control system of the servo motor with ultrasonic sensor using Tinkercad software. Next, as for the scope for the experiment, we are focusing on the coding for the servo motor and ultrasonic sensor. And second one is the simulation and evaluation of Arduino using the Tinkercad online software. Next, I'm going to expand on the theory for the experiment. Basically, ultrasonic sensor is an electronic device that is widely used for detecting object or motion, while servo motor is used in determining a precise control of the angular or linear position. So as you can see from the figure attached, the ultrasonic sensor emits the sound wave and it travels at a specified frequency and then once it collides with the object will make the sound wave bounce back to the ultrasonic sensor. So the ultrasonic sensor will listen to the sound wave which bounce back to it. So simply said, if there is a motion detected in front of the sensor will send the data to Arduino Uno board stating that there is something near it, thus activating the servo motor to start moving and face the source of motion. Therefore, this servo motor with ultrasonic sensor control system will detect and identify the motion depending on the position or location of the motion, then sends the information to the Arduino Uno, which will analyze and eventually send the information back to the servo motor to execute the specific rotating angles according to the codes uploaded. Next, I'm going to expand on the circuit analysis. So the circuit consists of several components to ensure that it can operate efficiently. And just like any other basic system, it will have a sensor, controller, and actuator. And for our experiment, the sensor are the ultrasonic sensor parallel pins, which function to detect and identify the motion on the position or location of the motion. Well, the controller for the system is the Arduino Uno, which is a type of board that is commonly used in the most robust of the bunch. And then the actuator is the positional micro servo motor, which will indicate the distance of the motion detected by the ultrasonic sensor, in which then it will provide a response and start moving by rotating at a certain angle of rotation.
Okay, Assalamualaikum. My name is Aiman Ikmal bin Kamaldin. Now we will be looking at the procedure of this project. We will be using Tinkercad to set up the whole system. Okay, first thing first, open up tinkercad.com. If you don't have an account, you should create an account, sign in, and on your left here you can see circuits. Click on circuits and then you will see this green button here, create new circuits. Click on that and it will bring you here. Okay, on your right, scroll a little bit down, you can see Arduino Uno. Click and drag, go to search breadboard. We will be using mini breadboard. Click and drag. Okay, the next one is servo. Search on servo. You can see here micro servo. Click and drag. The last one is the sensor, which is ultrasonic sensor. Here you can see ultrasonic distance sensor. Click and drag. Okay, now we have all the components. Time to connect all of them together. So first thing first, let's connect the ultrasonic sensor pin to the digital pin number 4 on the Arduino board. Okay, next one is the servo motor sensor pin from here to digital pin number 2 on the Arduino board. Okay, next one, we will be using the mini board for the ground and 5-volt cable. Okay, for the ground cable we'll be using black color, connected to here. Okay, next one is red in color, 5-volt. Click and drag to here. Okay, next one, just now is from the ultrasonic sensor, now is from the servo motor. Okay, this one is ground. Let's connect it. Let's go to the right side here, connect it here up to here. Okay, right, and now the last one from the actuator servo motor is the 5-volt, is the power cable wire, red in color, here up until here. Alright, tidy it up a little bit, make it looks as tidy as you can. Okay, now connect the breadboard to the Arduino board from here to here, from here to here. Oops, my bad, this one should be black in color. Okay, let's continue. Connect the ground cable to the ground pin, make it tidy. Okay, now the last one, the 5-volt cable, the power cable to the 5-volt pin. Okay, now that the system already been set up, we need to add the code configuration into the control system. Click on code up here, you will see blocks. Click on blocks, click on text, click continue, delete these, and I've saved my codings in the Arduino Uno application. Copy it, go back here and paste it. We have already done the procedure for this experiment, for this project. The output of the simulation will be discussed on discussion section. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syed Hazmi bin Husni. So, I will continue on the discussion of the project. So, first of all, we will simulate the project in Tinkercad. So, what we have here is Arduino Uno board, ultrasonic motion sensor, and also a positional micro servo, and also a breadboard. So here, as you can see, if you click the ultrasonic motion sensor, there will be an object here. The motion can drag all the way in the space. So here, the space here is the where the motion can detect. The sensor can detect the motion. So outside the area, there's nothing happen. So try closing the motion to the sensor. As you can see here, the servo motor rotates at its max at 20 centimeter, and if it is closer than that, the servo motor will back to its original places, same as if it fall outside the area, there's nothing happen. So according to the Tinkercad system assembly, code declaration for the board must be synced with the connection. So as you can see it here, so in the coding, they need to here this is a digital pin number 4 with connected to the ultrasonic motion sensor. So for the pin number 2, this here, is connected to the servo motor. So the output declaration is also important in the code of the system. So this will set whether the servo motor, how much the servo motor will rotate. So we can find it here in the coding. So here, this is the output code. So this is the declaration you need to make. So for the difficulty of this project, however, it is to obtain graph for analysis purposes. So some of the variable needed to be measured in order to obtain an accurate graph, distance or range of object from ultrasonic sensor, and also the angle of rotating of servo motor. So this measurement needed to be done physically using a measuring tool like spooler or protector. So the data can be tabulated. So I think that's all.
Assalamualaikum, my name is Fatini. For the conclusion, coding and electrical fundamental were used during the design of the circuit and coding for the Arduino ultrasonic sensor, and the circuit are successfully designed by using Autodesk Tinkercad software by developing an experimental procedure and coding configuration. And throughout this experiment, a better understanding on each component function are also gained, whereas this help in gaining knowledge about the step of the servo motor with ultrasonic sensor attached to a system. And for the recommendation, since the experiment is done through online and exposure to real life experiment is also still required in order to develop skill in constructing the circuit, and the electrical component must be put precisely and organized to avoid a functionless circuit which leads to a failure of the developed control system. For a better and accurate experimental result, the sensor need to put at a strategic location for a better sense of the object and give an accurate position for the servo motor to rotate.
We will move to the question and answer. First, the question is what the difference between DC motor and servo motor? DC motor is a direct current motor, with two wire, power and ground, continuous rotation motor. When you supply power, a DC motor will start spinning until the power is removed. Most DC motor run at the high revolution per minute. For example, computer cooling fans or radio controlled car wheels. Next is servo motor. Servo motor are generally an assemble of four things. First is DC motor, gearing sets, control circuit, and the position sensor. Okay, thank you. That's all from mine.
For the Q&A session, the question is, what are the example of a real-life application which use the servo motor with ultrasonic sensor, and how do we use it? So I'm going to provide 3 examples for a real-life application. So the first one is the revolving doors or the automatic doors. So this one is the basic one or common one. So when a person wants to enter a zone, the sensor will measure the distance between the person and the door will then automatically open. So the second example is the curtain control. Okay, when someone approaching a window, the curtain sensor will detect the distance between the person and also the curtain. Then it will then give information to the curtain motor, which then will rotate, resulting the opening or closing of the curtain. Okay, the third one is the general protection. If we need to take care of something or protect something, we can put a setup where the minimum distance that we set can make a buzzer go off if anything trying to approach the object. So basically that is all from me. Thank you.
Okay, now for the Q&A, the question is, in the system code configuration, why does motion sensor input and servo motor output declaration are coded in the void loop section? So we need to know the function of void loop first. Void loop is where the major part of Arduino sketch is executed. So in there, the program will start after the opening curly bracket, runs until the close curly bracket, and then it will go back up to the top where it starts. So it is why it is called loop. So if I were to put the output and input code not in the void loop section, the system will only produce an output once. For example, in this project, if I were to put an object near the sensor at a certain location, then the system will only produce an output for the servo motor once, and if I were to move to a different position, then the system will stop. It doesn't produce another output. Same goes if I move to a different location for 2 to 3 times. Nothing will happen, because the system doesn't tell the components to loop all the inputs. So that is why we need to put these codes in the void loop section. Thank you.
For the questionnaire, what is the type of board that can be used instead of Arduino Uno? The first one is not MCU. The not MCU is essentially the same as Arduino. but with Wi-Fi built-in, so it can be connected to the internet. Also based on the ESP8266, which is far more capable than Arduino. It also gives you a variety of programming language such as Lua or Arduino Programming Language or APL. The next one is Raspberry Pi. The Raspberry Pi is the most advanced. It is a whole computer on a credit card size board with a monitor, a keyboard, and also a micro SD card. It will be an operating system and you get a proper computer. Nowadays it can be run for everything from vending machine to car dashboard. It also can be coded in pretty much any language such as Python or Node-RED. So thank you.
For the question and answer session, if the system applied in a real experiment, what parameters will affect the reading of ultrasonic sensor? There will be, for the answer is, there will be 4 parameters that can affect the speed of sound, which are temperature, relative humidity, change of pressure, and also change of concentration of carbon dioxide. Okay, that's all from me. Thank you.